Today, I'll be sharing about differentiation. So what is differentiation? Differentiation is a method that you use to compute the rate of change of a function f(x) with respect to its input x. It is also used to solve the maximum and minimum values. But what are the techniques of differentiation? We have 6 types of differentiation. The first one is power rule. It is used for functions of the form f(x) equals to x to the power of n. Second, we have quotient rule. Usually, if we encounter questions with division of 2 functions, we must apply the quotient rule. Third, product rule. It is used when differentiating a product of 2 functions. So, if the equation has 2 functions, we have to use product rule, which is u prime v plus uv prime. And fourth is chain rule. Chain rule is used for composite functions. Next, we have implicit differentiation. It is used when a function is not explicitly solved for one variable. For example, x squared plus y squared equals to 1. And the last technique is logarithmic differentiation. It is useful for functions involving products, quotients, or powers of functions. It also involves taking the natural log of both sides before differentiating. Without further ado, let's try answering some differentiation questions. The instructions said to find dy dx for the following function. The question is 3x squared secant x plus 2. First, we must know which technique we have to use to solve this question. Like I have explained earlier, if we are differentiating the product of 2 functions, then we must use the product rule. And the formula for product rule is dy dx equals to u prime v plus uv prime. But first, we have to identify which one is u and which one is v. So the prior part of the equation is u, while the latter part of the equation is v. But where do we get the prime from? We have to differentiate u and v first in order to get u prime and v prime. Now, like I have said before, u is the prior part, which is 3x squared, and v is the latter part, which is secant x plus 2. Now, we have to differentiate them to get u prime and v prime. So let's differentiate 3x squared using the power rule. So f prime x is equal to nx to the power of n minus 1. Which means, for the 3x squared, the power 2 will be brought to the front and multiply with 3. 3 times 2 is 6, so we get 6. And the power 2 will be minus 1, so it becomes x to the power of 1, which is just x. So u prime equals to 6x. Moving on to the next, which is v. V is the latter part, which is secant x plus 2. So if we differentiate secant x, we will get secant x tangent x. And if we apply that here, v prime will become secant x plus 2 tangent x plus 2. Now that we have completed everything, all we have to do left is rearrange everything according to the formula of product rule, which is u prime v plus uv prime. So dy dx equals to 6x secant x plus 2 plus 3x squared secant x plus 2 tangent x plus 2. So that would be the final answer for this question.
Question 2, y equal to 4x plus 2 over cos x. So to find dy dx for this question, we have to use quotient rule. As we know, the quotient rule equation is dy over dx equal to vu prime minus uv prime over v squared. First, we have to identify the u prime, v, and v prime. U equal to 4x plus 2, u prime equal to 4, v equal to cos x, while v prime is equal to negative sin x. So we have to apply the u prime, v prime in the quotient rule. So we have dy over dx equal to cos x multiply with 4 minus 4x plus 2 multiply with negative sin x over cos squared x. After we apply in quotient rule, we have to simplify everything. So it will be dy over dx equal to 4 cos x plus 4x plus 2 multiply with sin x over cos squared x. So after we simplify everything, the final answer will be dy over dx equal to 4 cos x plus 4x plus 2 multiply with sin x over cos x squared.
And now let's move on to question 3. Question 3, given y ln 3x minus with e in the power of 2x plus 1 minus with tan for y equals to 0. So step 1, we need to differentiate both sides with respect to x. And the second step is to differentiate each term separately. We use product rule to differentiate d over dx y ln 3x. Product rule is u prime v plus uv prime, where our u is y, our v is ln 3x, our u prime is dy over dx, our v prime is 1 over x. Substitute all the number given in the formula. We got d over dx y ln 3x equals to dy over dx times ln 3x plus y times 1 over x. Next, we use chain rule to differentiate d over dx e in the power of 2x plus 1. And then we got 2e in the power of 2x plus 1. And we also use chain rule to differentiate d over dx, then 4y. And then we got 4 sec square 4y dy over dx. After we have done differentiate all the terms, we write the differentiated equation and then group terms with dy dx on one side. So we have here dy over dx ln 3x minus 4 sec square 4y equals to 2e in the power of 2x plus 1 minus with y over x. And lastly, we solve for dy over dx. The final answer is dy over dx equals to 2e in the power of 2x plus 1 minus y over x over ln 3x minus with 4 sec square 4y.
Okay, for the next question, we need to use the linear approximation to estimate the value into 3 decimal places. Okay, for the first step is use the given equation to let into fx. We use the 80.99 into equal to x. Then we do the fx differentiation, and after that we determine the x is the given value 80.99 and x0 is estimated value 81 because the x the 80.99 is closer to 81 than 79. Then for the delta x is x minus x0. That will be 80.99 minus 81. So the answer will be negative 0.01. And for the next step, use the formula and enter the value. As you can see at the top, that is the formula for the linear approximation. And then we just enter the value. As you can see, f in the bracket x0 and plus f prime x. Yeah, we use the other that we just did, the equation that we just did from the slide before this. Then after that, we just enter the value and wait for the next step. The final step, we can calculate and solve the problem. As you can see here, after we enter the value, I can solve it, and we can see 3 minus 2 over 9. It's not plus, it's minus. And plus 1 over 4 in the bracket 27 plus 1 over 729, and in the bracket is negative 0.01. And after that we solve and we get the answer is 2.778, and we just put it there because we want 3 decimal places and not more. Thank you.
As an average student, we face several challenges when attempting to solve this problem using implicit differentiation. First, recognizing that implicit differentiation is required can be difficult, especially if the student does not yet fully understand that y is a function of x and must be differentiated accordingly. The expression y ln 3x adds complexity because it requires the application of the product rule, which students often forget or misapply sometimes, treating y as a constant or incorrectly differentiate ln 3x. We struggle while applying this rule correctly, especially when multiple layers of function are involved. Overall, this question requires a solid grasp of multiple calculus concepts such as implicit differentiation, product and chain rules, logarithmic and trigonometric differentiation, as well as confident algebra skills. Without sufficient practice, an average student might find it overwhelming, but with guided steps and consistent exposure, it becomes manageable.